Hello, everyone, and welcome to Rajant's Partner Excellence webinar. Today's webinar is Warehouse Automation. My name is Todd Rigby. I'm a Director of Sales for Rajant, and I have the honor of being your host today. As a reminder, this webinar is being recorded and will be posted to our partner portal for future use. We currently have everyone muted except for our presenters. If you have a question, please type it in the chat feature. You can locate it by clicking on the three horizontal lines in the web meeting taskbar. We have multiple question breaks planned, and I will call on you to ask your question when it's your turn. Without further ado, let me introduce today's speakers. First will be Chris Wall, Director of Sales for Rajant. Then we'll hear from Gary Roblewski. He's the Robot Wrangler at SRSI. Stephen Griggs is filling in for Cody Robinson. He's our Sales Engineering Manager here at Rajant. And then Brian Mullenbach from Connectronics will wrap us up. I'll now turn the time over to Chris.
Yeah, thanks, Todd. So good morning, everybody. Chris Wall, Director of Sales, as Todd mentioned. I have primary responsibility for automated warehouse in the U.S., North America, and robotics. And so what I'm going to talk to you today about, my portion, and Todd, I still don't have control, so I don't know. I'm going to talk to you today about kind of what, when we go into a warehouse market, what is the opportunity? What are some of the challenges that the customers are facing? And so some of the contributing factors include anywhere from how do I reduce labor costs? I mean, the number one thing that they look at is, okay, I've got labor, very expensive. How can I reduce this? Can I go towards automation and help with reducing the cost? So that is a very big concern that they have. Labor constraints, as we mentioned, just add to being able to have robotics as a part of this environment, in the automated environment, and minimizes the amount of labor that you would need. So it takes out that manual labor force. And then you go to how do I increase constraints? So I want to minimize labor constraints. I want to increase constraints on minimizing that labor cost in there by adding robotics to help increase my constraints away from that. And then lastly, on that, how do I increase accuracy and productivity? I think this is the number one thing that they look at as a total picture is if I add in my robotics, my autonomous into the warehouse, how does that help me increase that accuracy and productivity? And Todd, I have the controls now, so I can take it. So then the next thing is, what are some of the hesitation factors that are included? And as we all know, there is a high initial investment cost when you add in automation. But if you look at the overall picture and how quickly we can get that return on investment, that's what the customers are looking at. Yes, it's going to be a high initial investment. Do we look at it as a CapEx? Can we move some of it to OpEx? We can have those conversations with them as we go along. The next thing that they look at is maintenance. So if I add in the robotics and I add in automation, how is my maintenance going to look? But when you look at the overall picture, the maintenance is a much lower cost than you would have for the labor cost. So that's one of the reasons that they would look at going towards automated warehouse. And then it does require some technical retention of folks, but you can take from multiple technical people on site and minimize that down to robotics and automation side. So you're kind of limiting the amount of labor force that you would have on that, but you're getting people that kind of know the system and so forth. So when we look at how Rajant performs within these automation type of warehouses, we look at some of the factors that they come to us with. And as we all know, when you put in your traditional wireless, whether it be CBRS, LTE, or some other faction of wireless, there's a big latency factor in that. Well, Rajant helps minimize that latency. So that latency is taken from probably seconds per hop down to milliseconds per hop when you go with Rajant. And that's key because, as you know, getting through a warehouse environment, doing the automation, if you don't have that connection, then your robotics are not moving. one of the main factors is the extension of existing wireless. So as we mentioned, high initial cost for install and so forth. One way that Ragent can help minimize that in a brownfield environment is, since we are layer 2 technology, we can encompass an already existing wireless infrastructure within the warehouse. And what that does is we just put in, if you have a Ragent breadcrumb installed, we just make it as a part of the wireless system, and then that wireless can be shown through the mesh as well. Ease of install, move, adds, and changes. As you know, with your traditional APs, you have a lot of factors that you have to consider when you're putting in an AP. With Ragent, since we mesh right out of the box, all you have to do is put it up, get it booted up. They'll mesh right out of the box. You set it up, and then you can move on from there. So it takes minutes versus hours to do some of these move, adds, and changes. And then as you change, it's as simple as moving that breadcrumb from one area to the other instead of having to recable every single time that you have to make that move, adds, and changes. The biggest advantage is the mobility piece. As machine-to-machine communication is critical, machine-to-machine communication with fixed asset points, AP points, is critical. And that's how we really can help extend that range within a warehouse, because you're having that mobility piece become part of the mesh, and they are passing traffic as they go forward. So that is one of the biggest key factors that we have according to everybody else. And because we are doing this in a dual frequency and our breadcrumbs are always connected to each other, you're always going to have that mobility piece be connected no matter where it is in the warehouse. Okay, as we said before, minimal initial setup. As I stated, it's minutes versus hours to do, so it's very key that they're meshing out of the box. And as I mentioned before, layer 2 that can work with current installations. And I think I touched that a little bit, but just to reiterate, that is key, because you can replace over time versus having to do a wholesale upgrade when you're doing your initial installs. And then ease of maintaining the breadcrumbs. We have a very easy process through our BC Commander that you can manage all your breadcrumbs. You get all the pertinent information, the feedback, what's going on with each one of the breadcrumbs. You get all that in our BC Commander. And then if there is an issue with any of the breadcrumbs, we have a very simplified RMA process that can come through and help analyze what is the issue with the radio, which is, I will say, very minimal, because we pride ourselves on having quality products out there at all times. And then with that, I'll take a breath and let if there's any questions that I can answer, I'll be more than happy to answer them.
Gizzy, I was wondering if you could maybe speak to who the sales targets are within this market vertical. Who are the people at the warehouses that you're specifically pitching to for warehouse automation projects?
Todd, I believe you meant Gary.
Oh, I meant Chris, actually.
Okay, all right. So
sorry,
I was gonna jump in there too, but anyway, that's fine. Yeah. So and that was a great question that we had previously. The targets that we look at, so when you ask a robotics company, and Gary can probably attest to this, the number one thing that they say is they utilize a pre-existing wireless that's in a warehouse today. So I guess the answer, Todd, is twofold. One is you want to identify that person within the warehouse that has that wireless responsibility. But I think the absolute key is you got to make sure that you're talking with IT, OT, and the wireless faction side of it. Also, if there's an automated side to their warehouse, you want to be able to have that communication. It's advantageous. Yeah, I can talk. It is recommended that you have all three on board, because you can't do one without the other. The hardest person that we have encountered to overcome is the IT person, but once you get them on board, then things seem to move pretty smoothly after that. So Todd, did that answer your question there?
It did. Thank you.
Yep.
We don't have any audience questions. Why don't we move on to our next speaker?
All right, there we go. I got control. Hi, I'm Gary Robleski. I work at SRSI. I'm on the software team. I specialize in networks and robotic systems. So today I'm going to tell you a little bit about Slate River Systems, how we partnered with Rajant to build a scalable wireless network to support our ASRS raft system. So Slate River Systems is an integrator, specializes in building custom solutions to help solve our customers' logistical challenges. These solutions often include automated conveyor systems, custom racking, workflow design within the warehouse, software consulting, and automated storage and retrieval systems, such as goods-to-person systems, which is AMRs, or our own unique raft system, right angle fast transfer. So to just cover the basic terminologies, just so we're all on the same page here, an ASRS system is a robotic system that moves goods within a warehouse using computer-guided robots. There can be various types of systems. These robots can carry bins, totes, cases, or entire pallets of product to different operations within the warehouse based on the workflow and the inventory movement requirements. Often these systems will have navigation capabilities using either QR codes that are placed on the floors, or some of them even have LiDAR and obstacle detection capabilities integrated onto the robot itself. So our raft system is a unique system that we built to be a fully rack-based system carrying entire pallets of product in through the warehouse and storage system. So we can have a put wall, which is a series of places where forklifts will come and put pallets of product. Or we can have conveyor in-feed systems where there's a single spot where a forklift will drop pallets onto a conveyor and that will feed through into the system. So on the induct side there, when they put product on either of those two in feeds, the robot will come and pick up those pallets. And based on the business logic that the company has worked through with us, we'll then slot those pallets into storage positions within our rack system. And then when they want to fulfill an order for that product, we'll pick that out of our raft storage and send it to their outbound locations for either further breakdown or shipping. Generally, this system is integrated with the customer's warehouse management system. Often it includes what we call our Swift Current Warehouse Execution System, which can coordinate all the movements of any of the automated systems within the warehouse, such as the vertical transfer units, chargers, and conveyors, and they can all work seamlessly. The vertical transfer units are the thing we can't call them elevators because they don't carry people, they carry goods. But our systems are anywhere from 5 to 10 stories tall. So they'll transfer rafts and product within the system to different storage levels. So what are some of the challenges that we face in the warehouse? First of all, we've got very large buildings, right? Sometimes in some of our warehouse systems, it'll be a 15-minute walk for me to go from the office location at the front of the warehouse to where our raft system is within the warehouse. So I definitely get my 10,000 steps a day in when I'm working around the warehouses. But this size also means it's challenging for cabling. The infrastructure components required to serve every spot in this building are steep. And so that's something that we hear customers talk about, and that's something that Rajant helps us solve with the mesh. So automated robotic systems rely on fast, reliable communications to work well. When they can't talk, they can't move. They all have to, we generally have a traffic cop application within our systems Even though the robots can be self-guided, they often need some coordinated traffic planning. Our particular RAF system, will wait till one robot confirms a movement before it clears a path for another robot. The faster you can communicate that information, the better that symphony of movement goes. If you can't communicate well, robots will struggle to meet their throughput targets. So traditional Wi-Fi struggles in that sense because of the handoffs that have to be done. In addition, with just standard traditional Wi-Fi issues, the more robots you add to a Wi-Fi system, the worse the situation gets. I'm going to show you a system in a little while where we're going to eventually have up to 100 robots and almost 100 fixed access points. That's a lot of radios in a large steel structure. So our RAP system is a large steel structure, and because of that, the RF performance can be very poor. We also, just to make matters worse, we have a constantly changing mix of products that move around in the system. So, when we plan a system, you do your best to figure out where things should be for coverage. But then as you get product into the system, you have to watch and make adjustments to it, so that you can overcome any obstacles that you find. So, and then the other thing is, we do have to deal with existing customer Wi-Fi, as was mentioned. Every warehouse will have existing 2.4 or 5 gigahertz Wi-Fi. Generally one of the top 5 name brands to provide coverage for their legacy devices, their RF scanning guns, and all that. So when we come in there with automation, unless it's a greenfield warehouse, we have to deal with existing channel plans and existing coverage, and so that that's something we have to overcome. So the last bullet point on cold storage, we've found our RAF system is particularly interesting to people that have to provide cold storage services, and there's some fundamental reasons there. Automation is one. You don't want people in very cold environments. It's not safe. So they need automation in these environments. They also need a lot of density because it's very expensive to keep a warehouse down to 0 degrees to store meat or frozen goods. So they want that storage as dense as they can possibly get it, so their cooling costs are lower. So that's where the automation and the density of our RAF system really helps out. But on the reagent side of things, we need gear that can withstand that sort of environmental condition. So the reagent gear is all certified for that low temperature rating, and it works well in that environment. So that's a great feature. So this is one of our deployed raft systems and one of the robots, actually an older version of a robot that can run in one of these systems. This system, when it's completed, will have approximately 65,000 storage locations, and up to 100 robots possibly. You're seeing essentially 1/5 of the rack. This is in the middle of a warehouse in the southern United States, and you're seeing the first phase of the implementation. That's approximately 21 lanes, and this will eventually go out to almost 100 lanes of storage. So the reagent product we have in here are peregrines for the fixed infrastructure. And we use ES1s and Cardinals in the robots for this system. So we chose peregrines because they support 4 channels and they have a high throughput. And with that many robots moving around, we wanted to have that flexibility for different channel plans. Perhaps we put half the fleet on 2 of the channels and the other half the fleet on the other 2 channels. So with the peregrines in that system, we've got that flexibility to make those sort of decisions. The ES1, I'll be frank with you, was a little bit of a challenge to fit into this robot because you can see that robot's, probably 5 inches, 6 inches tall. I was happy when the Cardinals were announced and were made available, because that's the unit we're going to use going forward. And my engineers on the robotics side are are very happy not to have to deal with the bigger connectors and all the size factors. They like to get that size back, that space back, so they can use it for other things and better cable management within the robots. So one of the things we found in this system after we started filling it, it took the customer about a month of building product into the system to start filling it up. But we did see some coverage changes within the system, and we had to address a coverage gap. So with the Rajant mesh, I was able to take a Cardinal that I had in my backpack, run a PoE injector to a spot within this rack, and then and deploy that Cardinal with 5 minutes of downtime on a production system and fill that gap. And so that was something that was immediate. I didn't have to really do any significant setup. I just put it out there, mounted a couple antennas, put the system back in service, and went about my business. But that allowed me to then take my time to analyze the radio situation better. And then on a Sunday when we didn't have production working in this system, I was able to tweak some of the settings, move some robots around manually, test things, and make changes to this live system. So that flexibility of the Rajant mesh really helped out in this scenario. So to summarize all this, so the Rajant mesh networks work well to cover these hard to reach areas. So we could pull cable to the outside of this system from IDFs mounted on the walls of the warehouse. And then we can use the mesh to carry layer 2 traffic within this system without having to pull more Ethernet. So that works well. Cardinals built into our robots really can provide great coverage. They provide multiple redundant links. We hardly lose a packet as the robot's moving underneath a product with batteries and coils and all sorts of things in it. In addition, we've got other projects that we're looking to use Cardinals on, where we actually mount them on the forklifts and provide a bubble of Wi-Fi coverage on a forklift, where an operator will use a scanner on 2.4 gigahertz traditional Wi-Fi to scan product, and using them in that capacity allows us to put less fixed infrastructure in because of the reach of the infrastructure access points and provide that bubble of Wi-Fi coverage to our operators. Again, the cold storage environment for us, which seems to be a popular market, the Rajant gear works well within that environment. We don't have to make any adjustments. We can purchase any of the products, and we know they're going to work just fine in that environment. So with that, I believe I'm done. So any questions?
You guys are really killing it. We haven't had any audience questions, but I'll go ahead and re-ask a question from our last session, Gary, specifically to the cold storage racking, where there is so little free space between the different levels of the rack systems. What special considerations do you take when designing and laying out the network to ensure good communications?
Well, so I try to plan coverage for my worst case scenario, and we build systems for clients based on their specific needs. So we don't have a cookie cutter footprint for our system. Generally it's a cube, but it can be a cube with longer storage lanes, going over pedestrian ways, things that are built outside. So I try to take the worst case scenario and build to that. I put more infrastructure in where I'm able to. Once you have a system that's full of product and in production, you really can't easily get into that system to make changes later. So you have to over-engineer it to start. And that's the pitch that I tell the customer. In this world, the expense of the radios is an insignificant blip compared to all of the other automation costs within the warehouse, and the ROI savings that they're going to have on this automation. So, you know, if I have to tell them that we're going to spend an extra $10,000 or $20,000 on access points, usually they're not, they don't balk at that, because they want to know that we don't have to shut the system down to go make changes later.
We do have a question here from Jacques Jordan. Would you like to go ahead and ask your question?
Yeah, good afternoon. Jacques speaking, yeah.
Good afternoon.
My question would be, you know, can you give us some guideline on the effect of the racking in the store? How does it affect your RF coverage? And what type of antennas did you deploy to overcome that?
So we're using the Radiant low profile antennas with the Peregrines. And I try to place the antennas, since the Peregrines have 8 antenna ports, 4 radios. I try to spread those antennas out, you know, from that fixed point. I generally will have 6 to 10 foot LMR cable to attach those antennas to get some diversity on the antenna. You know, my biggest fear within the racking system was, you know, it's a large Faraday cage. We're going to get lots of reflections of signals.
Yep.
And so what I've found is we often get better results by turning down the signal versus turning it up. We're not going for long distance coverage. So the system that I showed, that front face was the inbound side, 20 or so lanes, you know, 105 feet across the front, and is about 310 feet long. It's not a big system, 6 stories high. We deployed 30 Peregrines within that system. I wanted more radios that are at a lower power so that I could not generate a bunch of reflections and noise. And that has proven true. You know, where we've made adjustments, we've generally turned radios down.
Interesting, thank you.
Mm-hmm.
Thanks, Jacques. We've got another question from Anil Gadek.
Good morning, good afternoon, or good evening.
Oh, hello everyone. Sorry, I'm in a bit noisy environment, so I hope you can hear me clearly. My question is, what if the customer already has some wireless network and the robots have some wireless communications already, and how should we position Radiant in that case?
That's a great question. And that's a question that I overcame in this implementation and a couple of others. So one of the benefits that I found with using Radiant gear is that typically your Wi-Fi guys or your IT guys won't necessarily be familiar with it. So they won't know about it in advance. They'll have their, you know, HP, their Cisco, their Aruba, you know, Ruckus, whatever their standard consumer grade Wi-Fi solution in place. And they'll be comfortable with that possibly. But when I'm selling this type of system, you know, the racking system I showed you is, you know, when it's fully built, will probably be the largest system of its type in North America. You know, it's a many millions of dollars. So, you know, the strategy I took is I said, hey, you know, these guys, you know, this is a network for robotics. You're spending hundreds of millions of dollars on this system. You need the system to run right. And I will assure you that it will run right with this. And when they go and take a look, and I just reference this, and these guys, you know, the military uses them, mines use them, they're used in the toughest, harshest environments. And usually when they take a look at Radiant, where it's used, and they say, wow, you know, everybody I've shown the product to is, wow, this is really over-engineered, this is great. And they don't, you know, the IT guy doesn't want to be the one that makes the project fail. So you know, the objections fade away when you say, listen, you know, this will do what you need it to do, and I will support that from its entirety, from birth to death. It will run these robots. It will do it better than Wi-Fi. There are real technical reasons that it works better. And, you know, there are real reasons to deploy this within this automation system.
Gary, can you expand, if I understand
Okay.
just the question too? You mentioned one of the opportunities you had where the robot already had Wi-Fi existing, and how you meshed the Ragent in with that in that particular opportunity. Can you just briefly touch that one? I think that will answer some of the question too as well.
Yeah, no, that's a great example. So we started deploying the Raging gear for this customer in that warehouse with the raft system. Another division of this customer wanted to deploy a different type of robotics, a goods to person solution using floor moving AMRs. And you know, we're involved in that project as well. And they came to me, they said, hey, you know, this system seems to work really well in our raft system. Can you deploy the Raging, you know, infrastructure pieces for these other robots? So we did. We put them into their infrastructure, mounted them on the ceiling, and it's just replacing traditional standard Wi-Fi. You know, there were a couple of hurdles we had to overcome, because we couldn't get the Raging gear onto the robots themselves. The robots are manufactured in China. Export controls restricted our ability to get gear to China. And their engineers of the robots had some serious questions, but you know, we had the Raging engineer, Cody, went out there and went to their facility in Dallas, you know, proved to them that this will work really well. And so we deployed the Raging gear as infrastructure access points serving traditional Wi-Fi to these robots. And once we tuned things properly, they're working really well, and we overcame that hurdle. But it's interesting that you know, the initial response from that customer, you know, they recommended that solution for robotics to their own internal IT team from a whole nother division. And so we got the second sale for a totally different use case from that.
Well, thanks, Gary. We do have a couple more questions. I think we'll save them until after Stephen Griggs. They're a little more technical. And we'll now turn the time over to Stephen. Oh.
Hello, everybody. I'm going to apologize for any background noise you might hear. It just so happened that the landscaping crew decided it was time to cut the grass. So couldn't have been the timing couldn't have been any better. So with Ragent breadcrumbs in a warehouse, what does Ragent bring into the party? Well, one of the huge benefits, as Gary was kind of touching on, providing robotics something better than just the standard Wi-Fi client. You know, having these robots that become that you can make Ragent ready brings these things to a whole different level for many reasons. Because you know, there's so many limitations with just a standard Wi-Fi hotspot to client kind of situation. The thing that Ragent brings to the party, of course, is direct peer-to-peer communications. Now this is for a couple of different things, you know, depending on, you know, whether these robots need to understand their proximity to one another. Peer-to-peer, you know, makes that easier, but also because, you know, especially in this rack system that Gary was showing you guys, you can't have infrastructure everywhere, right? So one of the things that you know, Ragent kind of brings to the party is the fact that you can move packets from a robot through another robot to infrastructure. So it makes routing data and packet delivery much more dependable, in that you don't have to be within line of sight to, you know, an infrastructure point necessarily all the time. That's one of the beautiful things that you know, Ragent technology brings, is the fact that, you know, the mobility is kind of the bread and butter. So as these robots are moving around, and they're moving, you know, they're changing levels, and they're moving between, you know, all of this product in this raft system. So, you know, being able to communicate with each other on top of, you know, having communications to infrastructure brings a huge advantage in a system like this. You know, as we all might know, because we're all Ragent fans, the fact that InstaMesh is kind of a game changer, in that it's the routing protocol that just sends your packets from source to destination without anybody having to define routes or anything. And because those routes can change because of the mobility, and Instamesh is constantly recalculating those routes. It makes mobility in this situation, whether you're in a raft system or whether you're just using your forklifts and your robots in a warehouse situation. It makes routing your data, it makes it seamless, honestly, to the application. As Chris was talking about earlier with the low latency, and that means that all of the heartbeats for these robots are right on point all the time. Also, one of you guys were asking about how do we work with that? I think Gary touched on that some. Ragent can and seamlessly basically to a Wi-Fi, an existing Wi-Fi system already in place. As we all might know, Ragent is capable of being a Wi-Fi hotspot and servicing Wi-Fi wireless clients. We're also capable of being clients ourselves if there's already an embedded infrastructure that they don't want to get rid of. Now, we don't recommend that because there are several limitations to having Wi-Fi hotspots and clients in this type of scenario. If any of you have ever been to an arena and tried to use free public Wi-Fi or in an airport, free public, you have one access point to cover hundreds of clients. While you might be able to connect, your data is going to be really, really slow. So we want to make sure that for a system like this, where if you lose communications, robots stop, we definitely don't want that. So we want to make sure that those heartbeats and that data is right on point, is reliably delivered. So, but to answer that question, yes, it's very possible for you to drop in a Ragent system into an already existing Wi-Fi system and be able to have that communicate. That will work. Antenna selection and flexibility is something that Gary touched on. Diversity is something I'll get to in here in a future slide. Diversity is very, very important here because diversity relates to reliable packet delivery. Gary kind of touched on the fact that they're using, or he didn't touch on it, he said it. They're using peregrines. So peregrines, that's 8 antennas. So you can take that peregrine and you can spread those antennas around any cross section of that raft system, and you can really kind of spread it out, kind of spread the love a little bit. But you're spreading that coverage around so that no matter where that robot goes, it has at least one channel, typically 2, but at least one channel that it can see very, very well. So, so having those, being able to set those antennas, and those are the Ragent low profile antennas. They're omnidirectional, so it's very, very simple for them to, it's not something you have to think about. You don't have to think about pointing antennas in different directions. Those omnidirectional antennas, and they happen to be some of the same antennas that they use in the robots. So everybody's vertically polarized. Everybody's, and everybody is communicating really, really well. Those antenna patterns work really well inside that raft system. Also, as we all know, depending on what environments we're working in, because Gary talked about some of these, large, cold storage warehouses and stuff like that. Ragent runs in mining, in ports, in the weather, exposed all the time. So when you bring Ragent to the party, you're bringing a ruggedized industrial radio to the party that's capable of IP67 with a big, huge temperature swing. So you can get it cold and you can get it hot, and it just kind of keeps on trucking. So when we're thinking about antenna placement and these considerations, you have a couple of things to think about. First of all, if you're using this raft system, you do need to think about the size of the robot. You have to think about your head. You have to think about your headspace, right? And we need to think about how those antennas are speaking or talking. Excuse me. What does the radiation pattern look like? And that raft system looks fairly open until you start putting a bunch of pallets in there, and it starts to become a lot of hallways. So that's something that you need to think about. You also want to make sure that we're planning for sufficient backhaul. So The other advantage that Ragent brings to the party is the fact that you don't have to put cables on all of our radios. So Wi-Fi hotspots, you've got to run fiber and cable to everything. So that's a big impediment, especially in a situation like this, where when Gary talked about how he had a kind of a gray spot that had low coverage. His fix for that was to take a Cardinal out of his backpack and bring it and with a couple of antennas and an extension cord, and he was able to kind of to fix the situation pretty easily with, I think he said 5 minutes of downtime for the production system. Imagine if that was a hotspot. You know, you've got to run Ethernet cable, and you got to network it in and all that kind of stuff. So it's you know, it's a lot bigger of a production than you know, just putting out a Ragent breadcrumb and a Cardinal. I mean, you can put up a Cardinal with duct tape, you know, so at least temporarily. So so it's a very simple fix for a situation like that. We just have to make sure that we're planning when you start thinking about, you know, the integration of the system. You have to think about you know, your RF, but you also have to think about where your material is going to be and things like that. You can see that RAF system, you know, as Gary said, is a Faraday cage. You have to think about the high metal considerations. You got to think about the RF impact. I think Jacques was touching on that as well in one of his questions. So you do need to think about that, and you need to think about channel planning as well, because, you know, while you might not be using the existing Wi-Fi in the warehouse, you can rest assured that warehouse is going to have Wi-Fi in it. So that's something that you definitely need to think about. Do a Wi-Fi scan. See what channels are getting smashed. See if they can give you one. You know, if you're considering 2.4, we all know that there's 3 non-overlapping channels, 1, 6, and 11. And Wi-Fi hotspots are using all of them. So almost all the time, 2.4 is going to be kind of smash. So, you know, 5 gig gives you a bit more frequency flexibility. Also, it's going to move your data faster. We're not talking about long ranges here. It's a warehouse. So, you know, 5 gig is definitely could be a consideration here for a couple of reasons: your frequency flexibility plus your speed and performance. Also, you do want to make sure, because, you know, this is a 1 million square foot warehouse in this case, you want to make sure that you have plenty of ingresses into the network. As we all know, Ragent brings APT to the table. So you can have multiple radios, multiple ingresses into the LAN, which gives you no single point of failure, gives you a very reliable and resilient and redundant network, which is exactly what you need for these automated warehouse solutions. You've got to make sure that your communications is solid. So you want to make sure, like, if they've already run a bunch of, if they already have a bunch of Wi-Fi hotspots and stuff like that, they already have a lot of ingresses. So use them if you can. If you can reuse it, please do. Also understand, as a lot of our customers find out, if your wired network, if the warehouse's wired network is not correct, is not wired tight, APT will tell on you. All right, it's going to find the problems in the VLANs. It's going to find the loops. It's going to find all that stuff. So make sure that you guys have a networking plan to make sure that the VLANs are all set right. Make sure that your trunks are all right. Make sure there's no loops, all that kind of good stuff. So the biggest factor that Ragent brings is the reliability, the fact that we do redundancy. You know, frequency, we do channel redundancy, we do network ingress redundancy. Multiple radio frequencies with packets moving down all of them all at the same time. So we can transmit on one, we can receive on the other. Ragent is also built for mobility. You know, there was always mobility in mind when the Ragent protocol was designed. So we want to make sure that you know, you want to make sure that you bring that to the party, because these robots don't stand still. You're right; they're all moving around all the time. Forklifts are moving around all the time, and that's something that you can use you can use the forklifts to leverage communications for even the robots. So that's something else to think about as well. Ragent brings not only MIMO, but we also bring antenna diversity. So MIMO, as you all know, MIMO gives you that performance, that speed, that bandwidth. But the antenna diversity is kind of, that's kind of the meat and potatoes of this, because we're talking about reliability. You're going to find the performance of your application is going to improve with reliability over the straight up MIMO connection. You know, the straight up MIMO connection might be fast to one or two peers, but it's always going to throttle back, and and that's only one channel. So think about the reliability being a factor with if you don't have the retries, if you don't have the drop packets and all that kind of stuff. If I'm reliably delivering all of my data from point A to point B, no matter where that robot is, you're going to find that application is going to perform way better than if you had one or two MIMO, 300 meg MIMO connections, right? So you want to make sure that you're taking into consideration the redundancy and the reliability factor that Rajant brings to the party here. Let's see. And I just talked about the antenna diversity and the reliability improvement there. So that's pretty much all I had. Are there any questions that I can address?
We do have a couple. The first one is from Alan Munoz. He asked if I would read his question. He said he's got quite a bit of noise in his office right now, so I'll go ahead and read that. He says, I've been told the Cardinal module works better as an access point than the ES1. Is that true? And does the Cardinal give better coverage than the ES1?
So the only thing the Cardinal brings to the party over ES1 is its processor. So it's not any better of an access point. It's not any better RF coverage. It's not any better there either. What it does bring to the party, though, is it brings a higher level of throughput. So it has a faster processor. So, but as far as access point goes, capabilities and stuff, there's no real advantage over ES1. So it's mostly just kind of processor headspace is the biggest difference between the two.
If I could comment, in addition, one other thing to keep in mind when comparing the Cardinal to the ES1 is the Cardinal does have significantly lower transmit power. In a high density environment, that's not a problem. But if you're really looking for a breadcrumb to give you range, the Cardinal might not be your first choice.
Right.
The next question is from Sathiz Nair. I apologize if I mispronounced your name. Would you like to ask your question?
Yeah, I mean, basically, me from UAE, and the practice of here in the warehouses are all of them the height of 20 meter, and the rack physically is 19 meter height. It's narrow aisles. So how do we segregate the penetration when we have an AP's access point to get the lower level for the forklift or any other equipment as scanners?
That's a good question. So we found great success with doing ceiling mount stuff, but you can if there's a way to mount these solutions on the racks themselves, you're going to find really good performance. But as I said kind of before, putting breadcrumbs on your forklifts as well.
Yeah.
So
Okay.
if you're talking about because you can leverage the forklifts to kind of meet everybody in the middle, if that makes any sense. So if you put these radios, if you put these breadcrumbs on the forklifts themselves, on top of having there are antennas you can use for ceiling mounts to point kind of down. That'll go a long way. If you can do omnidirectionals on the racks themselves, you're going to want to stand the antennas off from metal racks if you can, absolutely, because that just causes reflections and things like that. So you want to try to stand them off away from metal if you can. All of those different things can help and make sure that you get good penetration. But the biggest key is put radios on your forklifts. That'll do.
And I think, and then in this case, we may need to have every aisles, right?
I'm sorry?
Yeah, I think then in this case, we need to have the antennas or IAPs in every aisles, like between
On
the
the
racks.
aisles? Yeah,
Yeah.
depending on the density, yeah, absolutely. Sometimes you'll have to put those on there. We found in some warehouses, if you use the cross sections,
Okay.
you can get antennas down all four ways. It's kind of like it's almost I kind of think about it like an underground mine in some cases where you have the cross cuts and you have to put antennas on at each cross cut. So sometimes in the aisles you can do four ways, and that'll help a lot as well. And in some warehouses we've actually been able to put one in a four-way intersection and then go down a couple of aisles and put one in another four-way intersection. And usually, depending on the height of the racks and the density and stuff like that, sometimes that'll be enough. But you really do need to do kind of a site survey. There's some software you can use to simulate aisleways and alleys and stuff like that. That'll give you kind of a visual on what that RF coverage could look like.
Sure. Thanks.
You're muted, Todd.
Well, thank you. Let's go ahead and turn the time over to Brian Mullenbach.
Hello, I'm Brian Mullenbach, working with one of Rajant's distributors, geographically located in North America, but we do have reach outside the United States. Connectronics is able to help enable the successful project deployments through the planning, some of our technical expertise, and then the shipping and logistics that we have experience with. So with the warehouses being built or existing spaces being renovated to allow the migration to Industry 4.0, they're taken into account every cubic millimeter of space. That used to be miles of wires and spaced out racks. That has been transformed to miles of RF wavelengths and compact racking to provide an efficient and continuous communication grid that is dynamic and an ever-changing environment. Rajant and Connectronics work closely with the integration partner to provide detailed and accurate quotes from the best way to power, run cabling, and mount each breadcrumb in an effort to help support meeting the initial project cost estimates. As the construction phases progress, Connectronics provides weekly status updates to ensure product delivery timelines are comfortably achievable. This is accomplished through holding dedicated stock for each project, which gives the integrator confidence and allows them to focus their time and attention on other parts of the deployment. Like all construction projects, unforeseen scope changes come up, which ultimately can require network coverage adjustments and modifications to be made. Connectronics provides the integrator with timely product flexibility due to our large amount of additional on-hand inventory. This helps the integrator in being able to accommodate the construction changes while keeping the installation on track. Getting into some of that technical expertise, some of the additional ways Connectronics can help with installation efficiency is with our detail-focused mindset and technical value adds. A few examples of this is providing custom design breadcrumb mounting solutions, as well as antenna cable assemblies. With both of these custom solutions, it enables integrators to overcome the complex and condensed environment by weaving in and around racking, and to help not create the unplanned obstacles for robots while building that continuous communications grid. Another variable to consider, even with the breadcrumbs being mounted in a quote unquote indoor environment, there's still moisture, dust, and heat. So antennas and cable connections will more than likely need to have some sort of weatherproofing. And this is another example of a third-party accessory that's outside the scope of Rajant. Just we want them to focus on the breadcrumb, and we can help provide those third-party solutions to the integrator to make it a complete solution. Another value add Connectronics offers is individually kitting breadcrumbs, putting all the necessary installation accessories for each breadcrumb in a single package to ensure the installation tech is not having to look around the supply trailer, walking all those miles back and forth for the ancillary accessories, ultimately wasting their time on site doing installation. Connectronics focuses on building and growing business relationships with manufacturers and integrators. We do this by balancing the short-term and the long-term mindset, be it project goals, and ultimately the end customer's desires and plans, which this provides integrators a firm foundation to build their business reputation on. It always comes down to execution. That's really where your reputation is built. And with the warehouse industry's push for a smaller and smaller footprint and same-day deliveries, within hours, reputation is really built on that execution of the many daily deliverables. Connectronics is geographically located and able to provide same-day shipping, up to 5 o'clock Central Time. We can still get you something out that day, and which is really helpful when end customers expect the supply chain to be able to deliver those sort of break-fix supplies overnight when they have maybe not decided to have on-site spares. Additionally, Connectronics is very experienced and comfortable handling shipping and logistics internationally. That has been proven to be of real benefit to many partners around the globe. Connectronics is 100% focused on supporting the integration partnerships through the distribution channel. We have grown our business with that mindset that we are serving and supporting integrators to help provide a positive and well-built experience for the end customers. We do this by remaining behind the scenes, being able to provide blind drop shipments and help enable that end customer relationship is very much focused with their integration partner. The support for the end customers continues beyond the product delivery and into the documentation. Once installation is all done and the warehouse is ready to receive and ship customer orders, Connectronics can assist the integration project managers with closeout reporting of hardware to ensure the warehouse has the information they need to successfully operate for many years to come. Thanks for showing your interest in learning how Rajant is enabling the successful warehouse automation transformation. What other questions do you have for any of the presenters that spoke today?
It doesn't look like we have any more questions. I would like to thank you all for spending this hour with us. I would also like to give special thanks to Gary Roblewski, Brian Mullenbach, Stephen Griggs, and Chris Wall. And I'd also like to recognize Gizzy O'Toole. He's busy behind the scenes, making sure these webinars run smoothly. And I would lastly like to thank those of you who asked questions, Jacques, Sunil, Alan, and Sathiz. Getting perspectives from partners around the globe makes these sessions much more interesting for everyone. We hope you found today's session informative. Please watch for an invitation to our next Partner Excellence webinar It will be on increasing sales and cash flow through forecasting and pipeline management, and will be held on June 5th and 6th. Thanks again for joining us, and have a great day.